This is Mrs. Carreri's help video for assignment for honors physics for equilibrium problems in ETA. Number one, they have a figure here that shows the person holding a pole as a pole vaulter. And notice it has the center of gravity on the pole in the middle because it's a uniform pole. And the force of gravity, which is also equal to its weight, is pulling downward. So that equals mg. We have the person's hands. One of them is pushing upwards. That's the left hand. They tell us this distance right here is, for me, 0.715 meters. And they also give me this distance right here. The distance between the two hands is 1.85 meters. And the first thing they do is ask for the magnitude of the force exerted by his right hand. So we're looking for the force that's pushing downward from his right hand. We don't know anything about the left hand or the right hand's force, so I'm going to pick the one that the left, so I can eliminate it from the torque equation as my axis of rotation. And about that axis, the weight causes a torque that will be negative, and I'll call that torque sub W for the weight of the pole. The force from the right hand is going to cause a torque in the positive counterclockwise direction, and I'll call that torque sub R, and that'll be positive. And since this is an equilibrium, we know that the sum of the torques must be equal 0. So all the torques added up equal 0. So 0 must equal the positive torque caused by the right hand minus the torque caused by the weight. Again, this is about the axis of rotation around his left hand. And why did I pick that? Because I don't know anything about the left hand force. I don't know anything about the right hand force, but if I've eliminated one of them, and they're asking about the other. So the torque caused by the right hand force is the force by the right hand times the distance away from the axis of rotation, which is 1.35 meters for me, times the sine of 90 degrees, which is 1. I'll write it, but we could ignore it. Subtract the torque caused by the weight of the bar, which is the weight of the bar, which is the force of that is mg, the mass of the bar, which they gave me the mass of the bar of 5 kilograms. So let's go ahead and write that. That is 5 kilograms times little g, which is 9.8 meters per second squared, times that distance from the axis of rotation, which is 0.715 meters. Now, if you notice, there's only one thing that there's only one unknown in this problem, and that is the force caused by the right hand. By the way, that weight is also multiplied times sine of 90 degrees, which is 1. That's why I ignored it. So I can find the force of the right hand. Now I know the answer to that in Newton meters. And then they want to know the left hand force. Well, I know all the forces except the left hand force. So I've got to find this by summing all the forces in the y direction. They must add up to 0. There is one positive force, which is the force by the left hand, and two negative forces. Force by the right minus the weight, and there's only one unknown now, and I can find it. All right, number 2. I'm only helping you set them up, and hopefully that's enough to help you solve the problems. Here's a bolt. I don't know how to draw a bolt. So here's my bolt, and here's my wrench. Okay, when tightening a bolt, you push perpendicularly on the wrench with a force of 165 newtons, a distance of, here's my force, perpendicular, so that angle is 90 degrees, at some distance away from the bolt, we'll call it D, and they want to know the torque. Well, the torque is equal to force times R times sine of theta. And in this case, we know the force, we know the distance, and we know the angle is 90 degrees. So hopefully you felt like that was pretty straightforward. Number 3, the uniform seesaw is balanced about its center as seen in below. The smaller boy on the right-hand on the right has a mass of 40 kilograms. So the force that's pushing down on the board right here is mg, which is equal to 40 times 9.8. And we know that we have a force normal from the fulcrum. We have force of gravity on the beam, which I don't know at this point. And then I have this force caused by the larger boy, which I don't know, and because I don't know its mass, because they're going to want to know its mass. So I don't know anything about the weight of the board, so I'm going to pick the axis of rotation at the fulcrum because I'm going to eliminate both force normal and force of gravity. And we know that these torques have to add up to 0 caused by these boys sitting on the bench. So I have the torque, I'll call that torque 1. Torque 1 is negative. Torque 2 is positive, and those torques have to equal 0. So 0 equals torque 2 minus torque 1, which equals the mass, force 2 is m times 9.8, and that's the mass that we're looking for. I'll call that mass 2, times sine of 90, that's at a 90 degrees, sine of 90 is 1, minus the torque caused by the smaller boy, which we know it's his mass, which is 40 kilograms in my case, again times sine 90. I now know that that equals 0. There's only one unknown, which is mass 2, and I can solve for mass 2. Problem number 4, same exact kind of situation, except this time notice the fulcrum is not in the middle, and so the force of gravity is acting on the beam in the middle. So this is the force of gravity acting on the beam, which they told me the beam they didn't tell me the beam. Oh, that's actually what they're asking for, is equal to mass, I'll call it mass of the beam, times little g. We know this boy's mass, he's a smaller boy, and that is the force of gravity, which equals 40 kilograms times 9.8. We know the larger boy's mass, which was 80, I believe, 80 kilograms times 9.8, and then we have force normal upward. So those are the forces acting on the beam. The one that I don't know is the force of gravity on the beam, because I don't know the mass of the beam. I don't know force normal, but the other forces I do know. We know this distance right here. So I'm going to have to pick one of those that I don't know as my location of my axis of rotation. So force normal I don't know. They're not asking about it, but they are asking about the mass of the beam. So I'm going to, if I pick that location as an axis of rotation, I eliminate it from my torque equation. That won't help me at this point in time. So I just need all the distances, and so we'll call this torque 1. That is a positive torque. I know that distance. We'll call this torque 2. That's a negative torque. This distance right here, well, where is that located? It's right smack dab in the middle of the beam, so that's 4 meters. So we now know that that's 1 meter because it's 4 minus 3. So there's that distance, and then I need this distance, which they told me already was 5. So I know all my distances that I need, so I need sum of the torques is equal to 0. So 0, I will then take my positive torque 1, subtract torque 2. This right here I'll call torque 3, and it's negative. And I'm going to end up with only one unknown in this equation. Torque 1 is 80 kilograms in my case, times 9.8 times sine of 90, minus torque 2, which is the mass of the beam, times 9.8 times sine of 90, minus the force of the smaller boy, which is 40 kilograms times 9.8 times sine of 90. And now I only have one unknown, which is the question that they're asking for. I hope that helps you. Come see me.